All right, so we went ahead and we jumped ahead to 1.5. Now we're going to go back to 1.4, and this is solving absolute value equations. So you guys probably have seen absolute values before. They are those little bars that we're going to get to in a second. We're going to go ahead and define absolute value for you. So in your book, absolute value has a real wordy definition. I like to think of absolute value as the distance from zero. So if you're thinking about this, it's like, the distance from your house to Terra Linda or from Terra Linda to your house is always going to be the same, no matter which direction that you're going in. And we use absolute values as these little bars, right? So these are what we call absolute value bars. And they talk about the absolute value of whatever's inside. So for example, on this one, if we're taking a trip back to middle school, you might have seen something like this. The absolute value of -4, and the absolute value of -4 is 4, because the distance from 0 to -4 is 4. But also the same thing as the absolute value of 4 is also 4, because the distance from 0 to 4 is 4. And they also, just as an FYI, they kind of work as parentheses. So if we have something like the absolute value of -6 times 2, make sure that you're going ahead and you're solving whatever is inside your absolute value bars first. So that's -12. The absolute value of -12 is 12. Okay, so those are the basics of absolute value, but when we're solving these equations, we need to have some steps. So steps for solving absolute value equations. And what I'm looking for is when x is inside these absolute value bars. So first step is you're actually going to isolate the absolute value as much as possible. We'll get to that in a bit. All right, and then once you have that, you're going to go ahead, you're going to break down those absolute value bars by setting up two equations. And one is positive, one equals negative. Then, of course, once you have those equations, you're going to go ahead and solve using inverse operations. And the last one is I'm actually going to put a little star by it because it's really important with these, is that you need to check. Check to make sure that your answers work. So let's grab some examples here for you so that you can see what we're talking about. I'm going to scroll this up so you see the steps, but we have some room to work. All right, example 1. I'm going to say the absolute value of x minus 4 is equal to 6. So when I'm looking at my steps here, I have isolate the absolute value. Check, that's done. All right, then I'm moving on to 2. Set up two equations, one positive, one negative. So this is what we mean by this, is that these two absolute value bars, switch back, need to be broken down. And one equation is x minus 4 is equal to 6, but the other equation is x minus 4 is equal to -6. Because my two options here for inside this absolute value bar is that it could either be a positive 6 or a -6. All right, so now we're going to go ahead and solve these. My inverse operation is add 4. X is equal to 10, so that's one option. And when I add 4 to this one, x is equal to -2. So before I go ahead and box these, I'm going to check my work over here on the side just to prove it to you. I have 10 minus 4. The absolute value of 10 minus 4 is the absolute value of 6. The absolute value of 6 is 6. So this guy works. Now let's check negative 2. Negative 2 minus 4. The absolute value of negative 6. That's also 6. This guy works as well. So both those answers work for this problem. Let's go ahead and let's try one that's a little bit more difficult. I'll leave that there. So example 2. 2 times the absolute value of 3x minus 9 minus 10 is equal to 2. So if I scroll back up a little bit and you guys have this on your paper, number 1 is to isolate the absolute value. So I like to use my highlighter and just highlight what is the absolute value. So I'm trying to get that by itself. And I need to use inverse operations to do that. So I'm going to add 10. That gets me 2 times the absolute value of 3x minus 9 is equal to 12. And once again, I'm trying to get this 3x minus 9 by itself. So I said 2 times, meaning that I'm going to have to go ahead and I'm going to divide by 2 and divide by 2. That gets me the absolute value of 3x minus 9 is equal to 6. Okay, now that was only step 1. So now I'm on to step 2 of breaking down these absolute value bars. So I like to go ahead, I like to draw kind of arrows to remind myself that I need the same equation, but one of them equals a positive 6. Same equation, one of them equals a negative 6. And from here, we solve. So 3x is equal to 15. And when you divide by 3, x is equal to 5. That's one answer. And if you'll notice here, actually the inverse operations are the same, but you get a different answer here. So x is equal to 5 and x is equal to 5 and 1. If you go back to the original problem, plug it in, they both work. Okay. They're going to get a little trickier as we get going, but stay with us. Let's switch over to, I like the salmon color. All right, example 3. This one is the absolute value of 2x plus 5 is equal to 3 times the absolute value of x minus 4. Okay, so up here on our steps, I went ahead and I said, isolate the absolute value as much as possible. So this is what we mean by as much as possible, is that on the left-hand side of our equation, it's isolated, and we're just going to go ahead, we're going to work with this guy. So here's what you're going to do. You're going to have to break down these absolute value bars, and we're going to say 2x plus 5 is equal to 3, and now I'm going to break down those absolute value bars and just write parentheses, because that's my positive one. Or, here's my other option. 2x plus 5 is equal to negative 3 times x minus 4. So now we need to go ahead and solve both of these. We're going to distribute. So we get 3x minus 12. I want to move my x's over to the left side, and I'm actually going to do this in the same step. I know I'm going fast on this one. So this is negative x is equal to a negative 17. Divide by negative 1, and x is equal to 17. So that's one answer. And then when you go over to the other side, you end up with a negative 3x plus 12. So watch your negatives there. So now when I add 3x and then also take away 5 here, we get 5x is equal to 7. I'm going to divide by 5. I can't reduce that, so my other answer is x is equal to 7 over 5. So you, of course, would go back to your original equation, plug these numbers back in. They both work. So for time's sake on this video, I'm not showing that check-in. Okay. Example 4, this is the big guy. I'm going to actually go ahead and star it. We're going to talk about a special term here. So 2x, the absolute value of 2x plus 12 is equal to 4x. Ooh, okay, so absolute value is isolated as much as possible. Check. Now let's go ahead, break down those absolute value bars. So 2x plus 12 is equal to 4x, that's 1, and then your negative answer. So 2x plus 12 is equal to negative 4x. All right, I always like to start on the left. Oops, sorry, I'm not going to do that one. I'm going to minus 2x to keep my x's positive. And then that gets me 12 is equal to 2x. So I'm going to divide by 2, and we get that 6 is equal to x. So this is one possible answer, and I'm going to go ahead, I'm going to go look at my other one. So on this guy, now I'm going to minus 12. You might not have done it that way, but that's okay. You could have done it a different way. And then I'm also going to add 4x. This gives me 6x is equal to a negative 12. Divide by 6. And we get that x is equal to negative 2. Okay, and this is the one I starred because I also starred this step up here at the top, is that you need to check your work. So let's go ahead and let's check this guy. I'll switch to a light purple when we're checking. So for this one, I have the absolute value of 2 times 6, I don't like that parenthesis, plus 12 is equal to 4 times 6. Let's go ahead and let's solve this guy. So absolute value of 12 plus 12 is 24, is equal to 24. 24 for sure is equal to 24. So yes, this guy works right here. X can absolutely equal 6. Let's check our other one. So now I'm going to have the absolute value of 2 times negative 2 plus 12 is equal to 4 times negative 2. All right, inside these absolute value bars, we have negative 4 plus 12. That's going to give you a positive 8 is equal to negative 8. Uh-oh. We should run into a warning sign right here. This is a big warning sign. Absolute value can never, ever equal a negative value. So this answer right here does not work. It's what we call extraneous. It's an extraneous answer. So definitely be careful and check your work. This one only has one solution, not two, like those other absolute value problems that we've been working with. So there's one last thing that you need to know about absolute value equations, and it's actually pretty simple, is the fact of if you have something like 2x minus 5 is equal to negative 100, I automatically know that this is no solution because distance, or absolute value, cannot be a negative amount. So it cannot be negative, meaning that my absolute value here is equaling this negative 100. Absolutely, I know right away, no solution. right, good job, Algebra 1. I'll see you soon.